Good morning. Welcome to today's mini lecture. Today I'm going to be talking you through some teacher-guided notes that's found in your notebook. So you can do one of two things. You can either print the notes off and then fill them in, or you can go back in and just simply copy down and write, as I do, on your own paper. So the very first thing, we're talking about states of matter. So we're talking about a solid, liquid, or a gas. So we have a theory that's called the Kinetic Theory of Matter, and you'll also hear it called the Kinetic Molecular Theory. Exact same thing. It's just talking about kinetics, that's the movement, and then molecules or matter, that's the same thing. So let me just kind of briefly explain this. Kinetic theory of matter says that all matter is composed of tiny particles, and these tiny particles are in constant motion. So I'm going to stop for just a second, and I'm going to let you write that down. So let me go back in, say it again. Kinetic theory of matter says that all matter is composed of tiny particles, and these tiny particles are in constant motion. So you need to make sure that you have that in there. That's big. So the way that I like to express this is I let my hands represent the particle. And these particles can be your covalent, like a carbon tetrachloride. It could be a water molecule. It could be anything, or just chlorine and a chlorine atom bonded together. But basically, it doesn't matter about the size of it. They're moving around, and then they're either going to be real close together, or they're going to be further apart, or they're going to be real far apart. So basically, what that does is that determines whether you're talking about a solid, a liquid, or a gas. So if I was to draw a solid, then the particles are going to be real close together. I'm just going to draw like this, and then I'll come back in and explain it. So the particles are so close together that they can't move around each other. They're just vibrating in place. Now, when you see this, you say, well, what causes something to make sure that the particles are so close together? Well, first of all, temperature is a big thing, but you also have to look at their IMFs, intermolecular forces. What's holding these molecules together? So if you have a lot of intermolecular force, such as a hydrogen bond or dipole-dipole, then it's going to take a lot more energy to get those to go apart. So what does a liquid look like? Well, liquids are going to look very similar. They still have a lot of structure to them, but now these particles are just far enough apart so that maybe after 10 collisions, maybe after 100 or 1,000 collisions, they can move around one another. So if they have enough space between them, as they can move around their neighboring particle, they just changed into a liquid. So if you think about a liquid like just water and you pour it out in a picture, you can see it rolling out. Well, that's the macro version of what's happening on the micromolecular level. These particles are moving around each other, so it has that ability to pour. All right, then I would like to go to a gas. What happens in a gas? Well, these particles are so far away from each other that they are just moving in random, and they can literally move for past one particle, 10 particles, 100 particles, 1,000 particles before they ever bump into one. So once they bump into one, and we're going to talk about this a little bit later when we start just focusing on gases, then as it bumps into it, then we're going to assume that it is a totally elastic collision. No energy is lost due to friction, and no speed changes or anything else. The final state is plasma. Guys, when we start dealing with plasma, we're not really talking about the alignment of the molecules anymore. We're talking about just pure energy. So really, if you're talking about plasma, you're talking about like the hydrogen fuel cells for the sun or a star. And if you're not, you're talking about a nuclear explosion. that's going to be when you're dealing with plasma. I always get somebody who says, well, are you talking about blood plasma? The plasmas? No, that's totally different. So we're talking about a state of matter, and it is the fourth state of matter, but we're not going to deal with that one in our class. We're only going to focus on solids, liquids, and gases, and in this unit, we're primarily looking at how these gases are going to act toward each other. So what I would like to do is I would like to take this same information and I would like to give it to you a different way. So I'm going to stop for just a second so that you can look at it. That's what you need to have written down. So when we start dealing with, and I'll erase, let me put gas back up here. And I'm going to erase the word plasma because we're not really looking at that right now. All right, so we're dealing with solids, liquids, and gases. So whenever I look at this, it does have energy as you go like that. So the energy increases. Sorry, I can't spell today. Energy increases. So what does that mean? Well, in order to get the particles really close together, it doesn't take as much energy. So this solid is going to have less energy than a liquid because it takes more energy to move those particles here, and then finally it takes the most energy to move them and separate them all the way out. We measure that energy as kinetic energy. And what does kinetic energy equal? Well, basically that is the way that we measure that in the lab is temperature. So the kinetic energy is based upon the temperature, and that is that motion or movement of molecules. So what I'd like to do is set up a little phase triangle, and I'm going to start with the solid down here, and then I'm going to move the solid to a liquid over here, and then I'm going to put a gas up here. So we can go in either direction whenever we're looking at this. You say, what do you mean either direction? Well, if I have a solid, I can go to a liquid. If I have a liquid, I can go to a solid. So what you have to remember is if I'm trying to go from a solid to a liquid, then that means I'm going from a lower energy to a higher energy. I have to place energy into the system. We call that an endothermic reaction or an endothermic process. If I'm going from a liquid higher and down to a solid, then it's called a exothermic. It's releasing the energy because you had more to start with. So just to make sure is if I go from a solid to a liquid, then you're talking about the melting point. If I go from the liquid to the solid, it is the freezing point. If I go from a liquid to a gas, then that is the boiling point. And if I go from a gas to a liquid, that is the condensation point. So now when we come over here, you probably are familiar with those different ones, but you may not be familiar with the nomenclature from a solid to a gas or a gas to a solid. So if you go from a solid directly to a gas, you skip that liquid part altogether. It's called sublimation. Sublimation or to sublime. And then if you go from a gas directly to a solid, it is called a to deposition or deposit. And all of a sudden you have a gas and then you just have solid particles starting to fall out on the bottom. So I wanted to go through these things in today's notes. Make sure that you have these put in. There's one little table that was in your notes. I think you can do that one by yourself. But if you need any help, you ask me during our face-to-face time. Other than that, what did we do in today's mini lecture? Number one, we talked about the kinetic theory of matter and how it defines a solid, a liquid, and a gas. That was the big thing. The kinetic theory of matter says that all matter is composed of tiny particles. These tiny particles are in constant motion. Now, like I said, right now, solid, liquid, and gas, but in coming up, we're only going to focus on the gas laws. How do the gases act in an ideal situation? So I hope that helped you, and I'm looking looking forward to seeing you in our next mini lecture.